for our SAT incremental practice session. I'm just checking very quickly to make sure I am live where I'm supposed to be live. And it looks like I am. Give me 1 second here. I'm not sure. There we go. Okay, so we are live today for SAT prep. We are going to be doing 3 questions from the reading and writing and 3 questions for the math. I'm actually going to start with the math first because I've been starting with the reading and writing each time. Remember, everything that I do today is available to you or for you on my website, kmjlearning.com, under free prep. You can download this, just fill out the form and you can download it. You can do that later. I'm going to project it on my screen now for you. So you don't have to do it right now, but you can download it. Also, if you're watching on YouTube, the link is in the description to download these. And you can even see previous weeks if you would like to. So today we're doing 3 math, 3 reading and writing, about 25 to 30 minutes worth of prep. I'm constantly saying that incremental prep over time is the best way to do this. And so I give you that incremental prep every weekday, Monday through Friday on YouTube. And we're going to start with math today. My name is Kathleen Jasper, and I am an expert in tests. So remember, for the math, you have the Desmos calculator. I highly recommend you use it. I also bring a handheld calculator. I think it's important to have like a quick handheld calculator for quick calculations, but also we want to be very familiar with the Desmos calculator because that Desmos calculator is a game changer and it's going to help you get a really good score on the math for sure. And I'm going to show you today how that works. So let's go ahead and have a look at my presentation here. We're going to start right away with question 1. Let me share my screen for math. So I'm actually jumping ahead a little bit. Usually math is the second thing you do on the test, but today I'm going to do it first because I always start with reading and writing first. So let's start with math. And right away, I see this here, XY plane. As soon as I see XY plane, I'm opening up that Desmos calculator. I can see that I have 2 lines here. They are in standard form, not slope intercept, but guess what? That doesn't matter because when I'm using Desmos, Desmos automatically graphs the line. If you were to do this by hand, you would have to change both of these into slope intercept. You would see they both have the same slope. They are the same line, but let's go ahead and put this all into Desmos here. Let me just pull this over a little bit. Pull this over a little bit here. Okay, so I'm going to take 4x plus 5y equals 20 and 8x plus 10y equals 40. Right away, I'm graphing it. I'm going to read all this, but I'm just going to graph it first and see what I get. So you can use your keyboard. 4x plus 5y equals 20. And then I'm going to hit enter. And I'm going to hit 8x plus 10y equals 40. Now notice these are all factors of one another. 4 is a factor of 8, 5 is a factor of 10, 20 is a factor of 40. These are the same lines because, and if I bring this over here, let's turn off the blue. You'll see the red appears. Let's turn on the blue appears. You can see that this is the same line, okay? Now, what it says here is for each real number t, which of the following points lies on the graph of each equation in the xy plane, the given system? Okay, basically, if you have a look here, do you see this? And I'll use my pen here. This is t over 2 plus 4, comma, t over 2 plus 20. This is x, this is y. This is x, this is y. These are plots on the coordinate plane. So what I'm going to do is, and I know these are kind of crazy, I'm actually going to plot these in my Desmos calculator. So let me pull this up again. And if you were taking this on test day, obviously you're not talking it out, you're doing it much quickly, but here's all you have to do. You grab this and do T slash, and if you put slash, it'll right away do the fraction. And I have T over 2. I'm going to hit the arrow plus 4 because look, if I don't hit the arrow, then I'm going to put plus 4 under there. That's not what I want. Look, it's T over 2 and then over plus 4. You got to hit that arrow, comma, T over 2 over plus 20. Okay. Now I need to put these all into here. They need to have their parentheses here. Now, one thing that I like it to do is to give me a slider, but for some reason it's not doing that. But do you see this little mark here? what you can do is, and I figured this out today, I'm going to make this less than 10, and I'm going to make this, I don't know, 0. And do you see how this thing is sort of off this blue line? It's asking which point lies on the graph of each equation, which one lies on this line. So it looks like this green one here does not. So A is out. I'm crossing that off. All right. Let's go with B here. So let's do -5/t. And then, nope, sorry. It's not 5, it's 5t/4. Arrow over, hit that arrow over so we can hit this plus sign. And notice I'm going to add a slider here. There we go. It allowed me to add a slider. Do you see what it did there? It made this dot a little bit bigger. I'm going to show you. I like adding the slider better. Go ahead and put my cursor back in there. I'm going to do this in a minute. I was looking for that option before. +5. I'm doing this one right here. -5t/4 + 5, comma, because these are x, y on the coordinate plane, t + 1, and I'm going to hit my parentheses there. Actually, I don't even need it. It did it for me. Okay, notice I have this purple one here. Now, if I zoom in, I'm trying to do this on 2 things here. If I zoom in, do you see that purple one is close, but it's not on the line. It's not on the line. Let's try the next one. Let's go to t, comma, and we have 4t/, this will give me the fraction, 5, and then over +4. You can see, let's go ahead and do this one here. Put it in your parentheses here, and we can click the label. We can label them if you want. You can click the label or not, whatever you want to do. And that red line is definitely not on it. So let's try this last one. It should be this last one. Let's go t, comma, negative. We got 4t/. It's under the question mark if you're using the keyboard. You can also use, oops, so sorry about that. You can also use this keyboard here. I like to use my actual keyboard on my computer. And again, you want to be practicing doing this. You don't want to just start doing this on test day. You want to be practicing with Desmos well before that, okay? And you can see that I have this one here, the blue one. Oh, look at the blue. The blue looks like it's on the line. Let's zoom in a little more. Yeah, blue looks like it's on the line. Now watch this. If I hit this play button here, look what these dots do. They go in and out. And which one is on that line? It's this last one. Now, be careful. This purple one is close, but if we zoom in, and you're going to want to zoom in for Desmos, you're going to want to zoom in here. And you can see that purple one is not on the line. I'm a little zoomed out here. See, but the blue is. The red definitely isn't. The green definitely isn't. It's way out there. So we want to make sure that we're grabbing that blue. And the blue was D here. Now, again, let me stop this. We took a little bit of time to do that. Okay. But you're going to be doing it much more quickly on Desmos. Now, let me show you. It gave me the slider option, but let's just say, and see these arrows here, that means the slider option. But let's just say I'm going to take these off because I want to show you what happens if you don't get the slider option. If you don't get the slider option, let's do parentheses. I think it's when you do your own parentheses first, it won't let you. I think you have to wait, well, or you add the slider beforehand. But let's just say I didn't add the slider. +4. This happened to me today when I was practicing. t/2 over +20, right? Okay, notice that I don't get the slider when I write the whole thing first. Notice that I have this option underneath. I'm going to make this less than 10. And if I zoom out, do you see? Kind of shows the way that green dot was running back and forth. That's not on the line. Let me show you what this one D is, just so you can see. Let's say I do it on my own without the slider. -4t/5 over +4. Again, I've got this. I don't have the slider like I did before, but let's add the 10 there. Oops, 10. Notice that purple line here. Do you see it right there? It's on the line. So that's another way you can do this if you don't get the slider option. But I recommend the slider. And the way you do that, I believe, is by grabbing it when you have t/2. It starts to give you the slider. I would click that and continue on with your problem here. Now, the last time I did this, I was able to choose the slider after I had done the whole problem. T over 2 plus 20. I'm going back to that first one there. And yeah, you can see like it gives me that slider. So sometimes you have to fumble around with it a little bit. Last time I did it, I could choose slider or point. But, look here, you can see these two are going up and down the line. And the only one that's on the line is this one here, which is the last. That's D. So just play around with Desmos at home. Get to know this calculator. The sky's the limit with this calculator, but it will definitely help you. This question would have taken a really long time. Let me just give you an idea. You would have to basically plug in, you could do it this way. So let's go 4x plus 5y equals 20. This is X, this is Y. So what you would do is you would take 4 times T over 2 plus 4 plus 5, and this would be T over 2 plus 20 equals 20. And then you would distribute. You've got fractions here. It would take so long, and you would do that for each answer choice, plugging it in. And when you got an answer that was like 20 equals 20, then that would be the answer. But why do all that? Just use Desmos and be on your way. I'm here to get you to the correct answer, the quickest and the most efficient way. This is how you do that. All right. All right. Let's take a look at the next one. We're not going to be using Desmos anymore for this. So what we're going to do is we have the perimeter of an equilateral triangle. So be careful. Equilateral triangle is 450 centimeters. So I'm just going to attempt to draw an equilateral triangle. Not bad. So when it's equilateral, all of the sides are equal, right? But its perimeter, which means all three of those sides, equals 450 centimeters. The height of this triangle is k square roots of 3. Okay. And this would make this a right angle. All right. Now they're trying to give you some information on special right triangles or special triangles, which I'm going to close out my Desmos here really quick for you. Yes, we're going to leave that. Let me just pull this out. And they're trying to confuse you a little bit here, but you don't really need to do this. You can do this by just understanding that this is an equilateral triangle. So let's have a look at this. 450. What's 450 divided by 3? Okay, this is going to be 150. Each side is 150. Now, if we're saying the height is k square roots of 3, but the height is right there at the very top and the very bottom. So that would kind of make this particular triangle split in half right here. So what's 150 divided by 2? That's 75. The bottom of this triangle, they're basically turning this equilateral triangle into a right triangle here. And when you do that, this little side right here is 75, and this side is 75, totaling 150, because the equilateral bottom of the triangle is 150. But when we split it and make the height k square roots of 3, where k is a constant, you're looking for the value of k. Now, what are they really doing here? All right, so let me show you what this equation is. So when we have a right triangle that is, let me just pull this up here. I'm going to try to draw a nice right triangle here. When we have a, 2a, a square roots of 3. Basically, we're trying to figure out, it's saying what is k here, right? It's asking what is the value of k. They want to know what this bottom is here. Now, this is a normal, these are the normal values for this kind of a special right triangle. It's it's 2a, a square roots of 3. Okay. This side, the long leg, the hypotenuse is always 2a. The shortest leg is always a, and the second to shortest leg is a square roots of 3. Well, because we know this is an equilateral triangle, we know that, sorry, I'm just going to redo this part here. This bottom is 150, right? Because 150, 150, and 150 all equal 450. So when we split this in half, this becomes 75. And if we're using this particular special right triangle, we know that A is 75. So 2A is 150. That makes sense, right? A is 75. 2 times 75 is 150, which gives us this. And then A square roots of 3. This is 75 square roots of 3. K is 75. All right. In this case, they're using A, but it could be, it's the same. Let's go here. And am I still projecting properly? Yeah. If this is K, 2K, K square roots of 3. It's the same. They're just using a different variable, but it is the same. Let me move this over here. There we go. All right, so very easy. They made it easy on you. They gave you an equilateral triangle. So we know that all the sides, each side is 150 and they all add up to 450. All right, let's have a look at question 3 here. Circle C has a radius of 4m and circle D has a radius of 100m, where m is a positive constant. I can't say that word today for some reason. The area of circle D is how many times the area of circle C? Okay, on the test, you do get a formula sheet, which you should already know this. The area of a circle is pi r squared, right? So if we're looking for the radius here, and we don't really have to pay much attention to the pi, but it's fine. We have a radius of 4m. So we're going to plug that in. This is going to be pi 4m squared. This is circle C, and circle D is 100m. So this is going to be pi 100m squared. So let's go ahead and square this. This would be pi 16m squared. And this is going to be pi, and what's 100 times 100? It's 10,000 m squared. So we're trying to figure out how many times bigger is this one to this one. Well, that's simple. You just divide. You take this number here and you divide it by the smaller number, 16m squared. Now notice m squared cancels out and so does the pi. So really all I'm doing is 10,000 divided by 16. And 10,000 divided by 16 is 625. So we had to do a couple of things here. We needed to understand that the area of a circle is pi r squared. Then we had to plug in the variables or the numbers for the radius. We plug that in. We replaced R with 4m for the first circle C and 100m for the second circle D. We figured out D is much bigger than C, and we wanted to figure out how many times bigger in terms of area is it. We divide and we get this number here, 625. All right. So those are our 3 math questions. We did it a couple of different ways. We did a few by hand. You could also do this in Desmos or your handheld calculator. Notice I've got some detailed answer explanations in here for you as well. So check those out when you download this particular study guide. Let's go up to the reading and writing now. You got to pay attention to the reading and writing. This is a great way to get some good extra points in reading and writing. Let's have a look. Now, remember, I'm always thinking like a test maker. I'm looking at my task first, because I want to make sure that I understand exactly what I'm being asked to do. If you start up here and you read all the way down and then you read all these answer choices, you're going to forget what you read. I like to start with the task, and it says, which choice best states the function of the underlined sentence? All right, so I'm going to read the underlined sentence first. And it's here. Using data collected from 2000 to 2020 for a group of international companies, the team analyzed over 15,000 creative project outcomes in relation to the amount of time employees spent in natural environments. All right, what's going on there? It's talking about the data. They collected it from 2000 to 2020, and it's for a group of international companies, and they analyzed over 15,000 creative project outcomes. All right. Let's have a look. To summarize the results of the team's analysis, be careful. You sort of want to pick that because you've got data here, but it's not saying the results. It's just telling you they collected data. It was from this group of people. It was about these creative projects, and it was about employees in the natural environment. Didn't say anything about results. It's just telling you what the study is about and the data they use. So A is out. B, to present a specific example that illustrates the study's findings. No, findings are the results. That's the same thing. We can only have one correct answer. So A and B are definitely out because they're the same thing. They're just worded differently. C, to explain part of the methodology used in the team study. This is a methodology. Collecting data is the method that they use. All right. But let's say you didn't know that. Let's say you didn't understand the term methodology. I know this because I have a doctorate. I did a lot of studies. I had to come up with a methodology. So that word I am familiar with. But if you're a high school junior or sophomore or senior, you might not know what methodology is, but don't get rid of it because it could be it. Let's look at D. To call out a challenge the team faced. No challenge here. It didn't say anything about like, oh, but the people were unwilling to give their data or something like that. Nothing like that was explained, which leaves us C. And I didn't even have to read anything else. And sometimes it's best not to read anything else because have a look at this. The team found that the more time employees spent in the natural world, the more innovative their project outcomes were. That gives you the results, but that's not part of the underlying portion. That's part of the regular part. So if you read that, you might have it in your mind, the results, and you might be inclined to choose A or B. So be careful. Only read the underlying portion first. And then if you need more information, you can read the rest. But for these questions, only read the underlying portion first. Methodology, just so you know, is the way in which you collect data, organize the data, the questions you use, things like that. And that's what is happening here. We're talking about they use this data. This is when it was collected, another method. Group of international companies, another method, who they used. They analyzed it over 15,000 creative projects. Notice I'm describing the method, and that's why C is the best answer. All right, let's have a look at number 2. So this is typical, and I'm just going to move this up a bit so my face isn't, and let me move it over so my face isn't blocking the, let's just go like that. So my face isn't blocking any of the important stuff. Okay, here we go. So don't start reading all of this. Let's go here. Which choice most effectively uses data from the table to complete this example? All right, we've got data in the table here. We've got inventors, years active. Okay. Let's have a look at the last sentence, continuing to work backwards. In fact, so many inventions and associated records for this era have been lost that counts of these 4 figures output should be taken as a bare minimum rather than totals. It's entirely possible, for example, that, all right, so it's saying so many inventions and their records have been lost that these totals should be the bare minimum, meaning there could be more. That records have been lost. We don't know. There could be a lot. Thomas Edison could have invented way more than 1,093. Alexander Graham Bell could have done more than 18 and 5. Okay. So let's have a look here. A, Nikola Tesla had significantly fewer patents than did Thomas Edison, who is credited with over 1,000 inventions. Well, it could be that, but it's saying that there were so many inventions associated that the records have been lost. A doesn't look like that's it. This is supposed to be the bare minimum. So Nikola Tesla could have more. So A is out. B, Hedy Lamarr's 5 credited communication patents included only those made after 1858. Be careful of the word only in an answer choice. This is what we call strong language, and typically it is not the answer on the exam. The reason being is that they're taking an almost correct answer and making it incorrect by giving you strong language. So I'm going to cross that off. And then C, Alexander Graham Bell developed far more than 18 communication patents, and Nikola Tesla had more than 112 electrical patents. All right, I kind of like C because it's saying there could be more here. Let's have a look. In fact, so many inventions and associated records for this era have been lost that counts for these figures' output should be taken as bare minimums rather than totals. It's entirely possible, for example, that Alexander Graham Bell developed far more than 18 patents, and Nikola Tesla had more than 112 electrical. That could be true because the records were missing. I like C. Let's discredit D. Thomas Edison invented 112 electrical devices and only fit. There it is again. Only D is out, making C the best answer there. Okay. All right. Let's have a look at number 3. Again, working backwards, looking at this, which choice most logically completes the text? All right, and we have this here. Now I have this word however here. I want to be paying attention to this. That means I need to read above it because this last sentence here starts with a however, which means it's going to be the opposite or a rebuttal of the original. So let's read this. Large marine mammals, such as whales, can grow into immense sizes, and some researchers have attributed their evolution to such massive sizes to an abundance of food resources in the ocean. However, okay, so they're saying whales are big because of food, but then they say, however, there is no evidence of significant increases in oceanic food supply coinciding with relevant periods of whale evolution. Okay, so they're saying that might not be it, such as when the first large whales appeared, when several whale lineages underwent further evolution towards giantism, or when whales reached their maximum known sizes, suggesting that A, fluctuations in oceanic food supply affected different whale lineages. They're saying no, it didn't. However, no evidence. I'm going to cross off A. B, the evolution of larger body sizes in whales did not depend on increased food. That's kind of what I'm getting at here based on this. However, there's no evidence that the food did it. There must be something else helping these whales grow into giants, right? I like B. Let's have a look at C. Oceanic food supply was higher when the largest known whales lived. No, because that supports this first portion. But we're looking at this, however. We're trying to get this blank here after the however. C is out. D, whales probably would not have evolved to such immense sizes if the oceanic food supply had been even slightly higher. Whales probably would not have evolved to such immense sizes if oceanic. This doesn't make any sense. D is out. B is the best answer here. It's saying the evolution of larger body sizes in whales did not depend on the increase in food supply. That is going along with this rebuttal of the original sentence here. So be on the lookout for things like that. All right. So that concludes our 6 problems for the SAT. Let me show you where to get more stuff. I want to show you where you can find me on TikTok and other places. So if you want my full course, you can go to KMJ Learning. First, you can go to free prep here and you can put in your email. And when you do, you'll be taken to a thank you page where you can download all of the study guides that I use on these lives. So you can download prior days, prior weeks, and all of that. You can also catch me on TikTok here. So I am KMJ Learning on TikTok. I have another TikTok page with over 18,000 followers, and I have some SAT stuff on there, but I'm trying to get this new TikTok page going. So if you can, follow me there because I need 1,000 followers to go live on TikTok. Of course, we are also on Facebook. So if you use Facebook, or maybe your parents use Facebook, we're there. I also post these lives on Facebook as well, if that's your preferred. And then, of course, I am on YouTube every day, Monday through Friday, doing 30 minutes incremental practice of SAT prep. We'll be doing some other things as well, like writing papers and how to finish assignments, writing assignments, things like that. If you have any questions about the SAT or anything, you can put it in the comments below, and it would be my pleasure to film a video for you. Remember, we are KMJ Learning across all social platforms and on our website if you'd like more help. It's been a pleasure working with you today. I will see you tomorrow for more SAT prep. Have a good day.